In this segment, we look at squeeze-type resistance spot welding. As the use and types of advanced high-strength steel continues to increase and change in automotive manufacturing, so do the welding requirements for replacing panels made of these materials. To ensure the steel's high-strength properties are not compromised, the weld heat-affected zone must be kept as small as possible. One way of doing this is with a squeeze-type resistance spot welder. This method relies on the resistance of the material being welded, the force of the tips, and heat from the current in order to fuse the materials together. The welder for this demonstration is the AMH CompuSpot800HF. This unit is not only a resistant spot welder, it also has all the necessary attachments for nails, wiggle wire, molding rivets, spot shrinking, and more. As with any new or unfamiliar piece of equipment, always make sure to read the manufacturer's operating instructions prior to using it. To begin, ensure you have all the necessary clothing, eyewear, and gloves. Turn the welder on. The welder initializes and the setup screen is displayed. The setup screen shows the clamp model, the clamping force displayed in decanewtons, the welding arm, and clamp type. Below the setup screen is the power and time adjustment buttons. To the left of the setup screen are presets for storing up to 4 different settings. Across the top are all the selection buttons for the carbon rod, wiggle wire, nails, spot shrinking, pinch welder, and other settings. There's a safety override that turns off power to the welding tips, and an air override that turns off cooling air to the cables. The air pressure gauge and regulator are found below the control panel near the on-off switch. The C-clamp welding head has a fixed arm, moving arm, and a 2-step trigger. The trigger's first step closes the arm, and the second is for welding. In order to begin welding, you must press the pinch clamp button again and enter the manual mode. The clamp force is displayed and can be adjusted with the regulator. Welding amperage is adjusted with the arrows below the display. Welding time in milliseconds is also adjusted with the arrows below the display. For weld quality testing on an actual panel replacement, coupons should be cut from the discarded panel and the vehicle manufacturer's recommendations used for weld nugget size. For the purpose of this demonstration, we're using pre-cut mild steel coupons and the welder manufacturer's recommendations for weld nugget size. Ensure the test coupons are clean and free of all contaminants. The spot welder is set at approximately 200 decanewtons of clamping force, 7,000 amps of current, and 250 milliseconds of weld time. Stack the test plates together with a slight offset and place them between the welder arm tips. Gently squeeze the trigger until the jaws close. If the alignment appears to be good between the tips and the coupons, fully depress the trigger until the second beep sounds. Once you have heard the beep, release the trigger and the coupon. Place the coupon in a vise, attach the pull rod, and peel the 2 coupons apart. The weld nugget should peel away and leave a hole in the opposite coupon. The recommended weld nugget diameter for this sheet metal thickness is 5 millimeters. If the pieces break apart cleanly, the weld current is too low. If the current setting is too high, there may be a splash of molten metal present between the 2 coupons. In either case, adjust the current setting and test again. When the current is adjusted higher, be sure not to increase the amount of weld time because it will raise the temperature of the surrounding metal and possibly damage its molecular structure. Only if the current has been maximized without producing a satisfactory weld should the weld time be increased. As more and more manufacturers utilize advanced high-strength steels, the squeeze-type resistant spot welder will become a common piece of equipment in all auto body repair facilities.